fuck. Uh that was too much. I'm not going to be able to do that. Anyways. All right, so slice type. Slices let you reference a contiguous. The fuck does that mean? Why am I searching the translation? Sharing an edge or a boundary. Slice lets you reference a contiguous sequence of elements in a collection. Okay. Slice is a kind of reference, so it does not have ownership. Okay. Here's a small program problem. Write a function that takes a string of words separated by spaces and returns the first word it finds in that string. If the function doesn't find a space in the string, the whole string must be one word, so the entire string must be returned. Okay. Okay. First word function takes a reference and optional output. We don't need ownership, so this is fine. Hey, Tinkle. We don't need ownership, so this is fine. Idiomatic function ownership. Let's see to. Or should we say we don't really have a way to talk about part of a string? However, we could return the index of the end of the word. What? We could return the index of the end of the word indicated by space. Oh, okay. So that means we would have something like hello world, and it's talking about this index, which is 0, 1, 2, 3, 4. So O equals 4. So it returns this. Return 4. We could return the index at the end of the word, yeah. Let's try that. Okay, so it's returning a U size. The heck is a U size? It doesn't explain. A U size in Rust, which is the size of a pointer in bytes. Oh, okay. Interesting. Maybe I should write that down. Let's use this one. The size of primitive is how many bytes it takes to reference. That doesn't really explain it. Hang on a sec. Let's use this one. It's a better explanation. Okay. All right, so we know what usize is. So it's going to return a usize, which is the length of s. But actually, doing let bytes equal s as bytes. Okay, so it takes. Does it tell me what this is? We'll convert our string to an array of bytes using the as bytes. Okay, and then for I, and so I is index, and this is a reference to something. What is that a reference to? Oh, whatever this is gets assigned to this. Which comes from this. And it's just doing if item equals B, this is the byte for a space. So if there's a space, then return I. But why do we return this? I don't get it. Because we need to go through the string element by element and check if the value of the space will convert our string to an array of bytes. Next, we create an iterator over the array of bytes using the iter method. I'll discuss more in chapter 13, but for now, iter is a method that returns each element in a collection and that enumerate wraps the result of iter and returns each element as part of a tuple instead. Oh, okay. So the reason we do this is because of this. Therefore, the first element of the tuple returned is the index. The second is a reference to the element in here. This is a bit more convenient than calculating the index ourselves, because it returns a tuple, we can use patterns to destructure that tuple. Yeah, which is why we do this. And inside the loop, we search for the byte that represents a space. Yep, we got this. And if we find a space, we return the position. Otherwise, we return the length of a string. Oh, right, of course. Okay. So it's going to return either this or this. Of course. Of course it does. I completely forgot how returns work. Of course it does. So it's going to either be the index where the space is, or it's going to be the whole string, because there's no space. Got it. We now have a way to find out the index. The end of the first word string, but there's a problem with turning usize on its own. But it's only meaningful. But it's only a meaningful number in the context of the string. Okay. The string reference. In other words, because it's a separate value, there's no guarantee that it will still be valid in the future. Okay. True. Now consider the program that uses the first word function. First word, we made it here, now we're using it. We make a mutable string, then we let word equal the result of this. Word will get the value 5. Yes, because it's this. And then it empties the string, making it nothing. Word still has the value 5, but S no longer has any content. So word is now invalid. Okay. Yeah, true. True. It gets problematic. Therefore, now we're checking the starting and an ending index, and we have even more values that were calculated. We have 3 unrelated variables floating around that need to be kept in sync. Luckily, Rust has a solution called string slices. A string slice is a reference to contiguous sequence of the elements of a string. How do you read this word?
Contiguous.
Contiguous. Okay. Contiguous. Sequence of the elements of a string, and it looks like this. Okay. Rather than reference to the entire string, Hello is a reference to a portion of the string. Okay, you specify the indexes or the indexes. And then the first position in the slice and ending index is one more than the last position in the slice. What does that mean? We create slices using a range with brackets. Yeah, that part makes sense. And then where a starting index is the first position. And ending index is one more than the last position in the slice. Oh, because it's counting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which corresponds to the ending index minus the starting index. Wait, what? Internally, the slice data structure stores the starting position and the length of the slice. Okay, so it's... Yeah, 5 minus 0 is 5, 11 minus 6 is 5. 5, 5. True. So in the case of let the world equal this, world of this less equal to the point of the binder for 6, with a length 5. Yes, okay. And that's the representation as a diagram. Yep. Pointer 0, length is 11, because it's 0 to 10. Capacity 11, 0 to 10. World pointer here, length 5, 6 to 10. Got it. Okay. We're getting a summer. Tuffy! 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 Come here, please. No. Alright. With the range syntax, if you want to start at 0, you can drop the vowels before the 2 periods. Oh, okay. These are the same thing. Okay. If your slice includes the last byte of the string, you can drop the trailing number. Okay. Ooh, you can also drop both sides for the entire string. Interesting. That's good to know. Very clever. String slice range indices must occur at valid character boundaries. I don't get this. If you attempt to create a string slice in the middle, the program will exit with an error. Okay. In the middle of a multi-byte character. Oh. Okay. Yeah, it makes sense. All this information in mind, let's rewrite first word to return a slice. Type that signifies string slice is written as reference string. Okay, so it takes a string and then creates the bytes. It creates a bytes collection. From the string, then iterates over them, and if item equals character, space character, then it returns the string slice from 0 to I. Yep. Otherwise, return the whole string as a slice. Interesting. Turning a slice would also work for a second word function. Now have a straightforward API that's much harder to mess up because the compiler will ensure that references remain valid. How? How does that remain valid? Slices make this bug impossible and let us know we have a problem in our code. Using the slice version will throw compile time error. Oh. Cannot borrow S as mutable because it's also borrowed as immutable. Immutable borrow occurs here. Yeah. Recall from the borrowing rules that if we have an immutable reference, we cannot also take a mutable reference. Yes. Yeah. Because clear needs to truncate the string. It needs to get a mutable reference. Ooh. The print line after the call to clear uses the reference in Word, so that immutable reference must still be active at that point, but Rust disallows the immutable reference in clear and the immutable reference in Word from existing at the same time. Jesus. That's a mouthful. Okay. And the compilation fails. Also eliminated an entire class of errors at the compile tab. Yeah, it's pretty cool. What are we supposed to be doing today anyway? We're on day 4. So read the rest of chapter 4. Ownership and references, practice mutable versus immutable, fix common borrow checker errors in playground. Okay. I think we're basically finished though. Recall that we talked about string literals being stored inside the binary. Yeah, I remember that. Now that we know about slices, we can properly understand string literals. Type of S here is a reference string, or a string reference. It's a slice pointing to that specific point of the binary. Yes, this is also why string literals are immutable. String reference is an immutable reference. Okay. String slice as parameters. Knowing that you can take slices of literals and string values leads us to one more improvement on first word, and that's its signature. Okay, what did we have before? First word S, string reference. Oh. What was that? Ah, okay. A more experienced Rustician would write the signature shown in listing 4.9. Instead, because it allows us to use the same function on both. Ah. Okay. Because I guess an str is a subset of this string. Improving the first word function by using a string slice. Yeah. Wait a minute. So it's string literal versus str. Okay, yeah, it's yeah, okay. So str means string slice. which is immutable. And string is a string which is mutable. If we have a string slice, we can pass that directly. If we have a string, we can pass a slice of the string, or a reference to the string. This takes advantage of deref coercions, a feature we'll cover. What the heck is that? Implicit deref coercions? Chapter 15. Holy shit. 21 chapters. Building a multi-threaded web server. Bro. We'll get there eventually. We're on chapter 5 for now, I think. Or almost chapter 5. Okay. Where's the rain mood when you need it? Rainy mood. My tea's gone cold, I'm wondering why. Okay, we're gonna win this. Ooh. Don't like that. Oh, and then he's gonna do that. Fudge! I fucked this up so bad. Ah! Ah! No! Oh, fuck you. Whatever.
A few days ago, image editing changed forever. Google released Gemini Flash 2.5 image, coincidentally with the same nickname my ex-girlfriend gave me, Nano Banana. That has everyone buying puts on Adobe, because Photoshop is officially dead. Instead of learning how to use all these antique tools, you...
Wait. Photoshop is dead? No way.
You can now just prompt Nano Banana for changes, and it's able to deliver any photo alterations you can imagine, and most importantly, while maintaining the consistency of the original image. If you're an animator or graphic designer, this can unlock massive productivity gains. Like if you wanted to steal some Meat Canyon art and make it do something else, you can now...
Wait, is that Logan Paul? That's Logan Paul. The fuck? Holy shit. It's the same dude. Oh, it says on his shirt as well. The fuck?
art and make it do something else, you can now accomplish that with a single prompt. No talent necessary. Google is finally back to its roots building cool stuff, and Flash 2.5 is a tool that makes Stable Diffusion look like Microsoft Paint. In today's video, we'll take a look at all of its capabilities and find out if our Adobe puts will actually print. It is August 29th, 2025, and you're watching the Code Report. Not only is Nano Banana an exceptional image model that's already at the top of the LM Arena leaderboard, but it's also extremely fast and affordable, costing only 3.9 cents per image via the API. And hypothetically, Google has also trained an even more powerful Grande Banana, but it's unlikely the common man will ever get access to it. The upgrade that most people are talking about, though, is character consistency. If you start with an image of a person or pet, for example, the model can blend it with a different image or make minor changes to it without noticeably altering the original.
Interesting. So Photoshop is dead. What about Maple AI? Let's compare this. How do you spell amateur? Okay, this is a good one. Okay. That's pretty good answer. And now Maple AI. Okay. Pretty good. Tuffy, stop barking, please. What about this part? It's not complex with general relativity. It's the formula theory. Renormalization. Hey, what's up? Dość now. Actually, Maple does a pretty good job. Alright, so then what about... How can I implement a simple... Let's see. Let's compare. This is a bit noisy. So I'm turning it down. Okay. Okay. First pass. Yellow is correct letter, wrong position. Green is correct. What is it talking about? Okay, and how does maple do? Interesting. Okay, maple is pretty good actually. How much is it? Wait, is it using other AIs? What? Pay with Bitcoin? What? What is this? Wait a minute. How does it manage login data? Oh, it uses React. No. Really? Hmm? Okay, this is taking too long. Oh, there we go. Mm. Okay, well, I disagree with that. I don't think it's required. It doesn't make sense.
Character, or multiple characters and objects like this guy did by blending 13 different images together. That means if you want a LinkedIn headshot of yourself wearing a nice suit, but can't afford to buy an actual suit, Nano Banana has you covered. In addition, if you work for the shadow government, it can be used to implement Mandela effects, like removing the cornucopia from the Fruit of the Loom logo. That's cool, but if you're a wannabe game developer, one of the main showstoppers is the insane amount of time it takes to build up a collection of good-looking assets for all your characters and animations. Well, now, if you start with a base character, you can prompt all the different positions required for an animation. Or better yet, just have Gemini generate an entire sprite for you with all of them in a single prompt.
There's no way. That's too powerful. Holy